Here is today's problem. The equation is x plus 1 over x equals 10 over 3. We want to find the exact numerical values for the variable x. The equation contains two separate fractions at the very start. Working directly with fractions can sometimes make algebra difficult. It is usually easier to clear the denominators right from the beginning. We can achieve this by multiplying the entire equation by a common term. Let us look closely at the denominators we currently have present here. On the left side of the equals sign, the denominator is the variable x. On the right side, the denominator is simply the whole number 3. We will start by multiplying every single term by the variable x. This requires the assumption that x is not 0 to proceed safely. We distribute this multiplication by x to each of the 3 terms present. The very first term is x, so we multiply x by x to start the process off. Multiplying x by itself gives us the squared term we call x squared. The second term is the fraction 1 over the variable x. We must multiply 1 over x by the variable x in this next step. The x in the numerator and the x in the denominator cancel out entirely. This complete cancellation leaves us with just the positive number 1. Now we must move over and multiply the right side of the equation by x. The right side is currently the fraction 10 divided by 3. Multiplying 10 over 3 by x gives us the new term 10x over 3. Let us clearly write down the newly updated equation we have created now. We now have x squared plus 1 equals 10x divided by 3. The variable x is thankfully no longer sitting in the denominator anywhere. However, we still have a fraction with a 3 on the right-hand side. We should definitely eliminate this remaining denominator as well. To do this effectively, we will multiply the entire equation by 3. We must remember to carefully distribute this 3 to every single term. We multiply the x squared term by 3 to immediately get 3x squared. Next, we multiply the positive 1 by the whole number 3. 1 multiplied by 3 simply yields a constant value of positive 3. On the right side, we must multiply 10x over 3 by the number 3. The 3's in the numerator and the denominator cancel each other perfectly. This leaves us with just the term 10x on the right side of the equals sign. Our newly updated equation is 3x squared plus 3 equals 10x. We have successfully removed all troublesome fractions from the problem. This is a standard quadratic equation because of the highest power of x. We need to arrange all of the terms on one single side of the equation. We want the other side of the equation to evaluate strictly to 0. We can easily achieve this by moving the 10x over to the left side. We subtract 10x from both sides of the equation to perform this move. On the right side, 10x minus 10x obviously leaves us with 0. On the left side, we now have 3 distinct mathematical terms to record. We currently have 3x squared, plus 3, and minus 10x. We should logically order these terms by the descending powers of x. The highest power is the x squared term, which goes first in the lineup. So we write down the 3x squared at the very front of the expression. Next comes the term with the single power of x, which is the minus 10x. Finally, we place the constant numerical term, which is the positive 3. The proper standard form is 3x squared minus 10x plus 3 equals 0. We can solve this standard quadratic equation by using the quadratic formula. The quadratic formula utilizes the numerical coefficients of b and c. The coefficient a represents the specific number positioned before x squared. In our specific equation, the numerical value of a is exactly equal to 3. The coefficient b represents the specific number positioned before the single x. In our current equation, the numerical value of b is negative 10. The coefficient c represents the constant term located at the very end. In our quadratic equation, the numerical value of c is positive 3. We will now carefully substitute these exact values directly into the formula. The formula always starts with negative b, followed by the plus or minus sign. Since b is already negative 10, computing negative b yields a positive 10. So we write down the positive 10, followed immediately by the plus or minus. Next, we need the square root of a specific internally calculated value. This entire mathematical value inside the square root is called the discriminant. The true discriminant is calculated mathematically as b squared minus for a c. Let us calculate this internal part separately to avoid making any algebra mistakes. First, we need to correctly find the numerical value of b squared for our equation. We must multiply negative 10 by negative 10 to calculate this b squared value. A negative number times another negative number always produces a positive result. 10 multiplied by 10 gives us a final squared value of exactly 100. Now we must proceed to calculate the second part of the discriminant formula. We need to multiply the specific numbers for a and c altogether. We substitute the value 3 for a and the value 3 for c into this product. We multiply the number 4 by 3, which predictably gives us a value of 12. Then we multiply that 12 by 3, which brings us to 36. The entire second part of the discriminant evaluates to the number 36. We must accurately subtract this 36 from our previously found b squared value. We subtract 36 from the 100 to mathematically find the final total. 100 minus 36 gives us a calculated result of exactly 64. The discriminant evaluates to a positive 64 for this specific math problem. This number 64 goes directly inside the square root symbol of our formula. So the top part is 10 plus or minus the square root of the number 64. We need to mathematically divide all of this by the lower denominator of the formula. The denominator portion is simply the number 2 algebraically multiplied by a. We multiply to by our starting a value of 3 to find the resulting denominator. 2 times 3 predictably gives us a final lower denominator of exactly 6. Our full expression is 10 plus or minus the square root of 64, all over 6. We can easily simplify the square root of 64 right now to clean things up. We are looking for a number that properly multiplies by itself to get 64. That specific number is 8, because 8 times 8 clearly equals 64. We will substitute this 8 directly in place of the longer square root expression. This substitution changes our top numerator, thusly to 10 plus or minus 8. The entire numerical expression is now 10 plus or minus 8 divided by 6. The plus or minus symbol tells us we have to separate logical paths to calculate. We must formally separate this single expression into two completely distinct equations. Let us rigorously calculate the first potential numerical value for the variable x. We will utilize the plus sign from the combined numerator for this first calculation. The numerator changes to become the simple sum of the integers 10 and 8. Adding the numbers 10 and 8 gives us a total numerical value of 18. We divide this 18 by the lower denominator, which currently sits at 6. 18 fully divided by 6 gives us an integer answer of exactly 3. The first fully potential solution for our current math problem is x equals 3. Now we must similarly calculate the second potential mathematical value for x. We will intentionally use the minus sign from the split numerator for this second path. The numerator predictably becomes the number 10 directly minus the number 8. Subtracting 8 from 10 smoothly gives us a remaining top value of exactly 2. We divide this resulting to by our formula denominator, which is still the number 6. This division ultimately gives us the fraction 2 over 6 as our next raw result. This particular fraction can be nicely simplified by dividing out a common factor. Both the top numerator and the bottom denominator are evenly divisible by 2. We divide the top number 2 by 2 to simply get the positive number 1. We also divide the bottom number 6 by 2 to quickly get the number 3. The fully simplified fractional form is therefore precisely equal to 1/3. The second fully potential solution for our current math problem is x equals 1/3. We have successfully found two distinct numerical answers for the original equation. We must now carefully verify both of these derived answers to ensure they are correct. We will rigorously test the first derived solution by substituting 3 in for x. The original left side was specifically the variable x plus 1 divided by x. Substituting 3 carefully gives us the mathematical expression 3 plus 1/3. We definitely need to add a whole number to a mathematical proper fraction here. We convert the whole number 3 into a proper fraction with a denominator of 3. 3 is numerically equivalent to the mathematical fraction 9 divided by 3. Our working expression logically becomes 9/3 plus the existing 1/3. We safely add the numerators directly while keeping the lower denominator identical. 9 properly added to 1 gives us a completely new numerator of exactly 10. The denominator steadily remains 3, so the computed sum is 10 over 3. This fraction perfectly matches the right side of the provided original equation. The integer solution x equals 3 is officially confirmed as entirely correct. Now we systematically move on to test our second potential answer of 1/3. We substitute the exact fraction 1/3 in place of the original variable x. The first algebraic term in the equation becomes the simple fraction 1/3. The second algebraic term is 1 cleanly divided by the entire fraction 1/3. Dividing by a fraction means you must multiply it by its mathematical reciprocal. The strict reciprocal of the fraction 1/3 is simply the whole number 3, so the second term evaluates incredibly directly to the positive whole number 3. Our ongoing left side expression is now 1/3 plus the solid number 3. We again critically need a common denominator to add these two unique terms together. We convert the integer 3 into the fraction 9/3 once again. We logically add the two distinct fractions 1/3 and 9/3 together. The exact numerators 1 and 9 add up beautifully to exactly 10 once again. The calculated result is undeniably the fraction 10 divided by the number 3. This also completely perfectly matches the required target value on the right side. The fractional solution x equals 1/3 is verified and mathematically confirmed. Our final complete mathematical solution set contains the numbers 3 and 1/3. Thank you for actively taking the time to carefully watch this full math breakdown today. Please always remember to leave a like on this specific video and kindly subscribe.